Hi, my name is Justin.
Hi, I'm Rodolfo Zaragoza.
The items that we will be using is going to be our spring launcher, a spring, a marble, a stopwatch, 2 measuring tapes, and a protractor. We primarily use a 3D printer filament, and that's how we made the base and the rod. The way it works is the rod will go inside a spring where it will go inside the whole base. The spring will be compressed and let go, and we'll occasionally change the angle of where it launches so we could get the best results. We'll stack up some books, and that's how we'll have our marble launcher resting, and then we'll have it on a protractor as well, so that we could change the angles. The angles that we'll be using today is a 20-degree angle, a 30-degree angle, a 45-degree angle, and a 70-degree angle. Once all the angles are good, we'll use one of the measuring tapes to measure the length of how far the marble will be launched, and the other one is the height of with the books are at. And to minimize any errors, we'll attempt it 3 times so that way we could see the average distance.
So the purpose for creating a spring and launcher system is to demonstrate how launch angles play a huge role in affecting a projectile. And we are trying to experiment if angles really affect the distance a marble travels, but also how long it's in the air for. And at the same time, we'll be looking at the energies in the system, like the potential and kinetic energy, and how energies get affected by the different angles, by also considering the concepts of springs like Hooke's law. And at the same time, we'll be noting down different types of data. So as seen in the video, projectile kinematics plays a huge role in observing the path of the marble and figuring out how different angles affect it. As the marble is launched, it creates what looks like a parabolic path, which is like a shape of a U. And as the marble travels, it has both horizontal and vertical velocity. The horizontal velocity will remain constant, while the vertical velocity will initially increase and decrease as it gets affected by gravity. And by using the kinematics formulas, we can figure out how the horizontal and vertical velocities, and by using the vertical footage, we can see how long it's in the air for and what distance it traveled and the max height.
Before anything happens, energies do come into play with the springs compressing all the way back. Potential energy increases all the way, and that can be seen into the formula PE equals kx squared. As the spring is let go, the potential energy transfers into kinetic energy, and that happens because it's passing the equilibrium point. Therefore, that is how the marble is launched. And to find the kinetic energy, it could be used. The formula that is used is Ke equals 1/2 mv squared.
So to further add on to the energies, the energy in the system will start off being in the spring potential energy, and it will be turned into kinetic as the marble travels, and turn into gravitational potential energy. And so we need to find the spring constant, aka the K value, for the formula for potential energy. We'll use the idea of Hooke's law to find it. Okay, so first we will measure the spring before the marble is added to using a ruler. And when we tape this marble to the end of the spring, we'll see how much it's stretched. And in this case, before adding the marble, the spring is 4 inches, and then the stretch amount when adding the marble is around 0.25 inches. So the spring constant in this case is 0.25 newtons divided by meters. And also by using the horizontal velocity and the distance, the potential and kinetic energies can be calculated.
With our results, we found out that setting the marble launcher to a low angle allows the marble to be launched further, but its max point of like the height, it's a lot lower and it's in the air for less time. When the angle is set to 70 degrees, you could see that the marble max height is very high and it's in the air for a long amount of time. But it decreases but because of the angle being 70 degrees, it decreases the length of the horizontal length of the marble being launched.
So looking at the data table we have for the energies, we can see that the kinetic energy was the greatest when there was a shorter angle, and that's likely because it traveled a greater horizontal distance when it had the shorter angle.
To reflect the project, it shows how important the angle is in changing the projectile path of the marble. Although there could be some error in this, as like if you don't compress the spring to the right displacement, all our tests and information show consistent amounts of information and D values that those mistakes that could happen.
To further add on from Justin, it also shows that angles affect height, time of flight, and horizontal distance. And it also showed how energies change throughout the system from spring potential energy to kinetic and to gravitational potential energy as the marble continues to fall in its flight of path. And that's the end, and thank you for listening to our presentation about a spring launcher system.